Okay, so we've got a car of mass 1,250 kilograms, okay, and it's ascending this hill, which is at an angle alpha, okay, so we've got to find out what this angle alpha is. So you can see the forces I've got labelled here, the attractive force, okay, pushing the car up the hill, okay, so that's the engine working there, producing this tractive force. So we've got a resistance of 1,550 newtons. But don't forget the weight component as well, you know, because when you're going up that hill, your weight is pulling you back, isn't it? And there is a weight component here. If we think of the weight obviously directed downwards to the centre of the earth, okay, we can work out the component in that direction by remembering that the angle alpha is the same as that angle there, yeah? Okay, so that's always, this angle is always the same here. Resolved in this direction then will be 1250g cos alpha, and then in this direction will be 1250g sin alpha. Okay, so I've got all the forces labelled there. That is important. Obviously we've got a reaction as well here, normal reaction. Okay, so I could add that in, but that's not really going to help us to work out the angle alpha, so I haven't bothered, right? I'm more interested in these forces in the direction of motion, okay, and that's where I'm going to apply Newton's second law. Let's see what else we've got. Well, we know the power is 30 kilowatts, right? So that means 30,000, yeah, watts. And of course, we told the velocity is 7.5. So those two connected using the formula, yeah. So we know power, for instance, now is tractive force times velocity, so I can put them in. Power to be 30,000, velocity 7.5, and then obviously take that 7.5 over, and I get my tractive force to be 30,000 divided by 7.5, and that comes out to be 4,000 newtons. So straight away now I've worked out what my tractive force is. So think about it, I've got my tractive force, okay, so I can use that now when I apply Newton's second law, okay, and hopefully we can get the angle. So applying Newton's second law, okay, obviously in the direction of motion, yeah, so we've got the resultant force, so we've got the tractive force pushing it forwards, take away the resistance, which is the resistant force there, and the weight component. That will equal to the mass, which is 1,250 times, of course, the acceleration. Now we're told something else as well, because it says it's travelling at a constant speed. So that means at a constant speed, acceleration is 0. So we can chuck that in there. Okay. So we'll have and of course tractive force we know is 4,000. 1250 there, g there's 9.8, and that will just equal 0, won't it? Because acceleration is 0. Okay, so we get, well, this becomes that's 2,450, yeah. If I take that away from that, I'll take this over to the side. So what have I got? 1,250 times 9.8, so I get 12250 sine alpha. Okay, so you can see what I've done. I've just take away that is 2450, and I've taken this over the other side, becomes a positive, and I've just worked that out to my calculator. And then of course take that over to get sine alpha. Okay, of course then to get alpha, I've got to take the sine over, do the inverse of sine. Okay, on my calculator, and I get my answer for alpha. So let's check it out. So we've got inverse, where are we? Inverse sine, inverse shift sine. So we've got 2450 over 12250, and I get my answer to be 11.5 degrees.